Okay, let's unpack this. For decades, satellite TV has had this one huge physical problem.
Distance.
Exactly. Distance. You've got the dish, and then you've got the equipment, and the coax cable between them can only really go about 100 meters.
Right. You push it any further,
Yeah.
and the signal just falls apart.
So if you're running a giant apartment building or a corporate campus, how do you even begin to solve that? You can't just put 100 dishes on the roof.
You don't have to anymore. That limitation is basically history, thanks to systems like this Thor broadcast F-LB41.
Okay.
This isn't just a piece of hardware, it's a total shift in infrastructure. It takes all four signals, the polarities, from the dish's LNB, and it turns them into light. It sends them down a single fiber strand for up to 40 kilometers.
Hold on, 40 kilometers. So you're saying,
Wow.
wait, the old limit is 100 meters, and this is 40,000 meters?
Yep.
An installer could literally use one dish for an entire neighborhood.
That's exactly the idea. Centralization, simplicity. And the key thing the sources point out is signal transparency.
What do you mean by transparent?
It means what goes in comes out. RF input at the transmitter is exactly what you get for RF output at the receiver. Your picture quality is perfect.
I see. So it works with the big guys like DirecTV, Dish Network, all that.
Fully compatible. It even supports tech like SWIM, the single-wire multi-switch systems. No problem.
That's critical. I mean, we saw the list price is just under $5,000.
Right, $4,995.
Is that a big ask, or does that investment pay for itself really fast when you're not, digging trenches for massive bundles of coax cable?
Oh, it pays for itself. Think of the labor savings alone.
Yeah.
You're running one tiny flexible fiber instead of heavy, expensive copper. The ROI is very quick.
Okay, this is where it gets really interesting for me. You said 4 polarities, 4 separate signals coming off the dish.
That's right.
How in the world do you cram 4 different signals onto one single strand of fiber without them just turning into a mess?
That's the secret sauce. It's all about light and color. The system uses something called CWDM.
CWDM, Coarse Wavelength Division Multiplexing.
Exactly. Just imagine you've got one road, but you're sending 4 cars down it, and each car is painted a different color of light.
Okay.
Each of the 4 LNB signals gets its own unique color or wavelength. They're all traveling together, but they're completely separate. The receiver at the other end knows exactly which color to look for.
So the signals are separated by color, but what about control? The dish still needs to get commands, right?
Absolutely, and that's part of the transparency. The system has a huge frequency response from 45 all the way up to 3,000 megahertz, so everything passes through. And crucially, it sends that 22 kilohertz control tone back up to the dish.
Which tells the dish which signal to send down.
Precisely. It's a perfect two-way street.
Now, speaking of the technical side, the sources were really specific about one thing, the connector. They say you have to use an SKPC connector.
An angle polish connector, yeah.
Is that a hassle for installers? Or just standard practice?
It's non-negotiable, really. With light, any tiny reflection at the connection point can kill your signal. The angle tip of the APC connector prevents that reflection.
So it's a must-have.
It is. But the unit helps you out.
Yeah.
It has a little LCD screen on the front that shows you the RF input power and the optical output power, so you can see right away if your levels are good.
Okay, let's zoom out. The bigger picture. This standard setup can already feed, up to 32 receivers?
Correct, using a single transmitter.
But what if you need more? What if you're talking about a massive residential development? What's the next level?
The next level is moving from CWDM to DWDM, dense wavelength division multiplexing.
Dense, okay.
And this is where things get really strategic. DWDM systems work with powerful optical amplifiers, EDFAs. With those, you can scale up to, and this is amazing, 5,000 or more optical receivers.
5,000 from a single satellite dish?
From a single dish. That's what Thor calls LTTH or L-band to the home. You can even start bundling in high-speed internet service over that same fiber.
So if you're the person managing this infrastructure, what this all really means is you have a system that's not just a fix. It's robust, it's transparent, and it's almost infinitely scalable.
It's leveraging light over copper to the extreme. And it leaves you with a really important question to think about.
What's that?
Just consider how many complex, high-maintenance, multi-dish setups out there right now, all running on old coax, are instantly made obsolete by a single hidden dish feeding thousands of homes with nothing more than a few strands of light.